Hey folks, so this is example 3 from the section 1.1 notes, and I sort of started doing some parts of it, but I want to take a little more time to explore this Google PageRank a little bit more. And let's see if your predictions were right. So in class, we predicted that the first website, X1 was going to be the most important one. So let's find out. So just as a review, the way we want to think about this is in order to determine the rank of a website, we want to say that the rank of a website is equal to sort of the sum of the contributions from the other websites. So for example, the value I assign to X1, we said would be, well, if I look at X2, X2 is lending some of its users to X1, and in fact, it's giving half of the users. Because there's an arrow going up from X2 to X1, but there's another arrow sort of going down. So I get half of its users. So I get half of X2, 1/3 of X3. I guess if I look at X3, there's 3 arrows and one of them going to X1. And I get how much of X4 stuff? So there's 2 arrows of X4, so I'm getting half of X4. And so that's the equation for X1, right? That's X1's value is sort of these 3 contributions. If I look at X2, on the other hand, let's see. So X2 is getting what? It's getting nothing from X1, right? Nothing from X1. It is getting some stuff from X3, right? It's getting 1/3 of X3 stuff. And it is getting half of X4. And I'll do the same for X3. X3 is getting what? It's nothing from X1. It is getting half of X2. Is it getting anything from X4? Nothing from X4. Okay, so X3 is just getting half of X2, and that's it. And then what about X4? X4 is getting what? All of X1, right? It's getting all of X1's usership. And it's getting 1/3 of X3's stuff. And I think that's it. Okay. So what I've just written down, these 4 equations, these are 4 linear equations. And we said these were linear because what? Every variable has a coefficient, which is a real number, a fixed number. And there's no squared, there's no square roots, there's no cosines, nothing like that. Okay, and everything's being added together. So yeah, this is a linear system of equations. One thing we can do from here is to translate this linear system of equations or just rewrite it so that it looks more like a standard form. So let me go ahead and do that. I have to kind of scroll up and down a little bit, I think. So, and by doing that, I mean, I'm going to put all the variables on one side, all the constants on the other. So that first equation for X1, I'm going to just move everything to the left-hand side. So X1 minus 1/2 X2 minus 1/3 X3 minus 1/2 X4. And now everything's set equal to 0, right? So in fact, there's no plus b anywhere. There's no constant term by itself. So it's just set equal to 0. All right, let me do the same for the rest of the equation. So now I'm going to do X2 minus 1/3 X3 minus 1/2 X4 equals 0. That third equation is what? Minus 1/2 X2 plus X3 equals 0. And that last equation becomes minus X1 minus 1/3 X3 plus X4 equals 0. And you might have noticed as I was writing down these equations, I was also reordering things so that it sort of went in 1, 2, 3, 4 order. Not strictly necessary, but it is certainly helpful for the next step I'm about to do. So the equations I've just written down are just the same equations we had before, but everything collected on one side. And now, just for practice, I can write this as the augmented matrix associated to it. Remember, the augmented matrix is the matrix that has all the coefficients from the left-hand side as well as that right-hand vector. Sorry, I wouldn't use vector in class, but the right-hand side zeros. Okay, so then the reason I wrote these things in order was so it's easier for me to write down all those coefficients. So moving along, 1 minus 1/2 minus 1/3 minus 1/2, 0. Now there's 0 x1s, 1, minus 1/3, minus 1/2, 0. Now I have 0, minus 1/2, 1, 0. And one more row is minus 1, 0, minus 1/3, 1, 0. So in the end, I got a 4 by 5 matrix, it looks like, right? This is a 4 by 5 matrix, it's 4 down, 5 across. And this is my augmented matrix, which I can now start using row reductions to try to solve this system of equations. So just for reasonable practice, let me do one step here just to remind you what that might look like, but I'm actually going to quickly stop doing it and you'll see why. So I'll start with that first 1 in the top left corner. This is first equation, and this corresponds to the coefficient 1 in front of the x1 variable. And so I'm going to use this as my sort of key entry of the matrix and then 0 out everything below it. You'll notice that a bunch of stuff is 0 already. The only thing that's not 0 is this -1. And it's already set up for me nicely that all I have to do is take rows 1 and rows 3, row 1 and row 3, add them together and use that to replace row 3. That'll 0 out very nicely. Ooh, you know what I can do in here that I can't do on the board is I can copy and paste. Let me go ahead and do that. I'm going to take this, duplicate it. There we go. And okay, so copy and paste the first 3 rows. And now I'm going to add rows, not row 3, sorry. I said row 3, but I meant row 4 everywhere. So add 1 and -1, I get a 0. Add -1/2 and 0, I get -1/2. If I add -1/3, -1/3, I get -2/3. Add -1/2 and 1, I get 1/2. And then 0 plus 0 is still 0. And there we go. So now I've started my row reducing operations. I've finished now that first column. Everything is all clear in that first column. And so I next go to the second variable. There's the 1 in that second column I can go to and start zeroing out below it. Now, what you're going to quickly notice is that these numbers are getting a little bit trickier, right? I have to start multiplying things by 2 or dividing by 2, right, to sort of get things to match up. And so a common theme in this class is, well, in real life, numbers are a little bit messy. Calculations don't work so nicely. And so what I will do and what we'll typically do in these situations is turn to MATLAB using a computer to help us solve these systems, okay? And so in practice, right, this is what happens. And so let me tell you that I did, in fact, go to MATLAB and have it finish the row reduction for me. And we got the following row reduced version of the matrix, okay? So you'll get the following. So you get 1, 0, 0, 0, and then 0.3214. Gets a little bit messy, as you can tell. 0.2142, 0, 0, 1, 0, 0.10714. Oh, well, okay. I chose to change the precision there, that's fine. And the last one, 0.3571. Okay, now from here, we have learned, right, if I read off sort of this matrix back in the system form, what you see is that 1x1 is 0.3214 and 1x2 is equal to 0.2142 and so on. So now I have solved the system. And in fact, if you don't believe me, you could take these numbers, plug them back into the original system of equations, and you'll see that everything is satisfied. Well, okay, there's a little bit of error because I've truncated these fractions into these decimals, but this is effectively in a solution. So what do we learn from this? Well, remember, the values here represented the relative worth of these websites or the relative importance of these websites. And perhaps the biggest surprise that you might have is that the largest number here meaning the most important website, was actually X4, which maybe was a surprise. So let's take a minute to go back up to see why we think X4 might have been the winner here. So in class, we sort of had a couple intuitions as to why X1 was the most important, right? Everything was getting sent to X1. And X1 was only sending its stuff to one place. But I guess that's the important thing to realize, is that although everything is directing itself to X1, X1 is sending all of its users to X4. And it turns out that that effect is important enough that X4 ends up being the most highly rated website out of the 4. And so it turns out this is the winner. So that's probably a little surprising. And I think this is a good moment to sort of sit and reflect on, you may or may not agree with this result, right? So mathematically, this is the result we have. And if you're unhappy with it, it sort of shows that, well, we made a choice about how we chose to model importance, right? We chose to do it as a sum of these, sort of contributions from arrows. And maybe that's not the right way to get the result. Maybe there's another way you can measure it, another metric that would make more sense. And so this is a big part of mathematics in the real world too, is that there's not always a single way to interpret the data. There's not always a single way to set up a system. So given the way we set it up, in fact, X4 ended up being the most important. But maybe another way would have given you a different answer. So I like this example because I think it's kind of surprising, but I think the thing to take away from this is we can set up a system of equations. They are linear equations, which means we can use all the row reduction methods that we've learned in class in order to get a solution to this system, and we can interpret that solution back in the original problem. Okay, if there's any questions, please let me know. But I hope you found this a little bit surprising and kind of fun. Okay.